The universe is not silent, it's alive with motion, currents and invisible structures shaping reality. For centuries we thought space was empty, a silent vacuum. But the twin Voyager spacecraft proved us wrong. Launched in 1977, they were meant for a 4-year mission to Jupiter and Saturn, but they kept going, venturing into interstellar space. Now they're our most distant explorers, measuring the flow of charged particles and magnetic fields far beyond the planets. These tiny spacecraft, powered by radioactive decay, have become our distant senses. They've shown us the void is full of turbulence and structure, where the sun's breath meets the galactic winds. Voyager's story is one of discovery, constantly challenging what we know. Even now, as they drift farther into the unknown, they send back puzzles, pressure fronts, cosmic echoes, and the true nature of our cosmic neighborhood. They are the pioneers, and we are still learning from them. In 1986, Voyager 2 became the only spacecraft to visit Uranus. It found powerful radiation belts but almost no low-energy plasma to feed them, a baffling contradiction. Where were the particles coming from? Scientists expected Uranus's moons to supply them, as Io does for Jupiter, but the data suggested the moons were geologically dead. For 40 years, this was the accepted story. Uranus and its moons were quiet, inactive, and fundamentally different from Jupiter and Saturn's dynamic systems. Uranus itself is strange, knocked on its side with a wildly tilted magnetic field. Scientists wondered if this chaos explained the missing plasma, but the numbers never added up. The Voyager flyby left us with a cold case, a snapshot that painted Uranus as a frozen, inert world. The implications were huge. If the moons weren't active, there was little hope for subsurface oceans or cryovolcanism. Our only evidence was a brief encounter, and as we later learned, that moment was misleading. The truth was hidden in the old data, waiting for a new perspective. The Uranian puzzle was far from solved. Sometimes, a single snapshot can deceive. Decades later, scientists revisited Voyager 2's Uranus data with modern tools. They discovered the spacecraft had arrived just after a rare solar wind event, an intense blast from the sun that swept plasma out of Uranus's magnetosphere. This event, happening only about 4% of the time, meant Voyager 2 caught Uranus at its most unusual. The missing plasma wasn't evidence of dead moons, it had just been cleared away. Suddenly, it's likely that moons like Ariel and Miranda are geologically active, possibly with subsurface oceans. The solar wind event had hidden their activity from view. This revelation rewrites the story of Uranus. It's not a quiet backwater, but a dynamic system, its secrets masked by cosmic timing. The lesson? Context is everything in science. A single data point can mislead without the bigger picture. Voyager's old data, re-examined, continues to yield new discoveries. Sometimes the answer is there all along, waiting for us to look again. The 40-year-old puzzle was a clue, not a dead end. Space is more dynamic than we ever imagined. After their planetary tour, the Voyagers crossed into interstellar space. Voyager 1 in 2012, Voyager 2 in 2018. We expected calm, but the interstellar medium was turbulent and structured. In 2020, Voyager 1 detected a sudden pressure front, a spike in magnetic field and plasma density, like hitting a cosmic speed bump. Scientists still debate the cause, a distant supernova shockwave, or the sun's interaction with the galaxy. Both Voyagers have recorded strange fluctuations, revealing the interstellar medium is lumpy with its own weather and currents. These aren't planetary movements, but the motions of the galaxy itself. Cosmic rays, tangled magnetic fields, echoes of ancient explosions. The Voyagers are our buoys in this unknown ocean. Why does it matter? The heliosphere, the sun's protective bubble, shields Earth from harsh galactic radiation. Understanding the environment just outside this shield is crucial for our safety and future exploration. The Voyagers provide the ground truth, helping us model our place in the galaxy. They are scouts on the frontier, reporting back from beyond our solar walls. Every bit of data helps us understand the forces shaping our cosmic home. The interstellar frontier is far from empty. It's alive with surprises. Even billions of miles away, the Voyagers still feel the sun's presence. Crossing the Heliopause wasn't stepping into a new room. It was entering a thick, complex boundary. The sun's influence fades slowly, its effects echoing deep into interstellar space. Solar storms, coronal mass ejections, send shockwaves that the Voyagers detect years later, even beyond the Heliopause. The sun's reach is greater than we imagined. The boundary between our solar system and the galaxy is dynamic, breathing with the sun's cycle and galactic pressures. The Voyagers reveal this cosmic dance where two great environments meet and interact. This knowledge is vital for future explorers. Understanding space weather and radiation is key to protecting astronauts. The Voyagers are mapping the hazards and wonders beyond our planetary shores. They're not just relics, they're our guides to the future. Before becoming interstellar pioneers, the Voyagers transformed our view of the solar system. Voyager 1 found active volcanoes on Io, proving geological activity beyond Earth. It revealed Jupiter's moons as dynamic worlds, not just cratered rocks. At Saturn, the Voyagers unveiled intricate rings and Titan's thick, mysterious atmosphere. Hints of subsurface oceans on Europa and Enceladus inspired future missions. Voyager 2 alone visited Uranus and Neptune, discovering new moons, faint rings, and storms like Neptune's Great Dark Spot. On Triton, it saw geysers of nitrogen ice, evidence of activity even in the coldest reaches. Each flyby was a revelation, showing a solar system alive with diversity and change. The Voyagers discovered 23 new moons and confirmed rings around distant planets. They showed us a dynamic family of worlds, each with its own story. The solar system was no longer static, it was a place of endless wonder. The Voyager mission was about more than science, it was about humanity's desire to reach out. Each spacecraft carries a golden record, a time capsule of images, sounds, and music from Earth intended for any who might find it. It's a portrait of our world, our art, our cities, our laughter, and our hope. The record includes greetings in 55 languages and a cosmic map to our home. In 1990, Voyager 1 turned back and took the pale blue dot photo, Earth as a tiny speck in the vastness. This image became a symbol of our planet's fragility and unity. The golden record and pale blue dot together capture Voyager's spirit, reaching outward, reflecting inward. The spacecraft may never be found by aliens, and their power will fade. But their true audience is us. They remind us of our place in the cosmos and our drive to explore. Voyager's legacy is both a message to the stars and a mirror for humanity. As of July 14, 2025, the Voyagers approach 50 years in space, a testament to human ingenuity. Their power is fading, instruments shutting down, but they persevere, sending back data from the edge of the unknown. They are our only direct link to the interstellar medium, refining our understanding of the cosmos. Their discoveries inspire new missions, IMAP, New Horizons, and calls for a Uranus orbiter. Voyager's legacy is not just in data, but in inspiration. They transformed our view of the solar system, revealed active worlds, and gave us the pale blue dot. They carry the golden record, a message of hope. They are cultural touchstones, captivating generations. Their journey is far from over. In 40,000 years, they'll pass near distant stars. They will wander the galaxy for millions of years, silent ambassadors of Earth. For now, they still speak to us, teaching us about the boundary of our home. The Voyagers are and will remain humanity's greatest voyage of discovery.